Today we're going to show you how to run our combined service drop pole and distribution pole placement algorithm on crosscompute.com. Use this tool when planning a grid extension. The tool is available on a monthly or annual subscription basis. Contact billing at crosscompute.com. The first step is to upload your customers as polygons or points. If you upload polygons, the algorithm will place each service drop line only to the edge of each customer polygon. You can upload CSV shapefile or CAMZ format. If you upload a shapefile, make sure to include each relevant shapefile file in a single archive. The algorithm will attempt to place service drop poles and distribution poles near roads when it is more cost effective to do so. If you don't have a roads dataset, you can download one from OpenStreetMaps. A pole obstacle is a polygon for where you cannot place poles, but where distribution lines can cross over. For example, a river or a stream. If you don't have any pole obstacles, you can simply upload the NoGeometry CSV. Similarly, a line obstacle is a polygon where you can place neither a pole nor distribution line. For example, an airport. You can specify here a minimum clearance distance around each obstacle where you do not want to place any poles or lines. For example, here we're specifying that 1 meter around each obstacle. We do not want to place any poles or lines. The obstacle simplification parameter is important when you want to increase the search space of the pole or line placement. So you can decrease this number if you would like to consider more locations for poles. If you have existing pole or line data and you upload it, in particular if you upload existing distribution lines, this is where it becomes a grid extension problem. Note that the map only shows the first 256 features, but don't worry, it actually uploaded the entire file. Here we set the different parameters for service drop line. Specify the minimum length, the maximum length. There are cases when the algorithm will violate these constraints, but it will do its best to try to respect them. There's also the maximum number of service drops per pole, as well as the maximum distance of a pole in meters as measured from the center of a road. This is used mostly to determine whether a pole is considered to be on a road or off a road when computing costs. And this is particularly an important parameter. Here you specify the maximum interval between poles. Typically, I think around 100, between 50 to 100 meters is fine. You should also specify the number of customers approximately within each community. Particularly for large data sets, you want to make sure that this number is somewhere between 50 to 100. For each customer, if you have not specified a specific customer demand in kilowatt hours per day, you can specify a blanket demand over here. This comes more important when planning microgrids. In the cost parameters, you need to specify the approximate cost of each service drop pole and distribution pole. The unit of currency does not really matter as long as you're consistent across all of these costs. You also need to specify the cost of service drop line per meter and distribution line cost per meter. The off-road cost multiplier is a critically important parameter. If you specify 1, the algorithm will ignore roads completely. Anything greater than 1, it'll use when computing costs and trying to figure out where to place a pole. For example, if you place 10 here, the algorithm will, as much as possible, try to place poles along roads. But note that that doesn't guarantee that it will place every pole along a road, especially if doing so will result in a much greater cost. In the algorithm parameters, you can specify different ways to restrict the search space of the algorithm if you, for example, want it to run faster. The bounding box you can use when the data sets that you uploaded are much larger than your area of interest. For the mesh interval, you can decrease this number if you want to have the possibility of exploring more options, but note that this will significantly increase the computation time. Similarly, for road, line, and pole sample count, increasing these numbers will increase the computation time at the expense of while increasing the search space. So you could possibly get better results if you increase these, but particularly pole sample count will significantly increase the execution time of the algorithm. Finally, this parameter is only available in the combine tool, the customer minimum distance from the existing line in meters. This just means that in the event that you uploaded a lot of customers and you only want to focus on extending the grid to customers that are at least, for example, 1,000 meters away from the existing distribution line, you can set this parameter to 1,000, or say 5,000 if you only want to consider extending the grid to customers that are at least 5,000 meters away from the existing distribution line. Note that when uploading customers, it's a good idea to upload all of your customers, even those that already have electricity, simply because the algorithm will try to avoid placing poles and lines on top of customers, and it won't know that a customer is there unless you specify it. If you signed up for a license, you'll have access to a manual worker that pretty much lets you run the tool as much as you want for the duration of your license. After you run the tool, the result will look something like this. So here, for example, the existing service drop line is in brown, and green is the new service drop line. So existing distribution line is in brown, and green is the proposed distribution line. The yellow-green here are the service drop lines. So you can see here how we've have the existing grid, we have the proposed distribution line, and we have the yellow-green service drop lines. This algorithm for this data set took approximately 5 hours to run. The execution times will vary greatly depending on the size of your data set. There's a cost summary that shows how many poles were placed off of a road, in case you haven't acquired all of your right-of-way. Finally, the algorithm does several checks to make sure that it followed the constraints that you specified. In this example, it was unable to respect the service drop line minimum constraint. And it was also unable to connect one service drop pole to the resulting network. And once the result is generated, you can download the result, and it has all of the files that you see above. And that's it.